I'm going to start talking about evaluating the proper amount of data. And my always knee-jerk reaction when it comes to evaluating the proper amount of data is a pseudo-imposter syndrome, where I start to think, there's not really going to be a way that I've known fully I've collected the proper amount of data. We have IoT devices, we have all these other different ways that we are creating structured and unstructured data for analysts and different applications all around the world to crunch about us. When you go to start to break these things apart, you can get hit with a deluge of different factors and features that you want to include or you don't want to include. The complexity of the problem and the algorithms that we're choosing are going to bound the rationality that we're starting to do with these kinds of things. The modeling decisions that I make in the world will dictate which courses of action I need to take when I start to collect maybe textual data off of Project Gutenberg, or if I'm going to collect certain stock data off of Google Finance. However, there's another thing that we can do is we can take another managed approach when we start to look at evaluating the proper amount of data. And this is what I'm talking about when I start to say about learning curves or reasoning by analogy. I could take the models that I'm considering. I could take data that represents a pseudo class next to my model of the world, and I could run these different models on my data to see how the model and the performance metrics would operate under certain conditions. After that, I could do the Delphi Technique, which is another fun way of just reaching out to somebody who has domain expertise or who is a subject matter expert inside of this field and glean the types of insights that they've gotten out of being as deep into the studies of that field as they have been for as long as I can. There's also conferences that you can go to and a lot of different ways that you can build up a large body of knowledge so that you can step forward accurately and modeling the world. Finally, there are certain rules of thumb that might be in place for us to start, and with a step climbing algorithm type step, we can learn as we grow, as we see our models grow themselves. That's what I'm measuring, these statistical heuristics, these factors of the number of classes or input classes. So if I go into the next slide, I'm going to start talking about the learning curves themselves. So the picture that I have right here is a pull from a research paper that Microsoft had when they were trying to build out a algorithm to classify images for text. So if I have some handwriting text, I'm going to compare it to other different things that look like an A, a B, or a C. What's the statistical likelihood that that's going to be an A or a B or a C written by someone's hand?